Okay, this is a review of the scientific method, and I'm going to go over the steps so that you can review this for your test that's coming up. Step one. Step one is you either need to identify a good question or you need to come up with a problem. A good question, we've said, needs to lead to an investigation, not a report, demonstration, or model. Remember, we said you might think it's cool to build a volcano or a hovercraft, but that's not an actual investigation. It needs to be something you can collect data on with your actual experiment. You can ask about how something may affect something else. You need to be very specific rather than broad, and your material should be really easy to find. Like we said, you don't need to have something that you need to go out and be able to, like you would have to go to a hospital and have specialized equipment. It needs to be something that you as a middle school student would have access to yourself. Writing a hypothesis is your next step. That's an informed statement about what the outcome of the experiment will be, what you think is going to happen. Remember, it's either an informed statement or educated guess. So it's not just what you think is going to happen, pulling that out of thin air. It is you researching your topic and basing it on prior knowledge. Keywords you can use in a hypothesis are because, increase, decrease, stays the same, greatest amount, and the farthest. This is the format that you use for a hypothesis, the if-then format. For example, if I go deeper in a lake, then the temperature of the lake will decrease. So you put it in this format, what you think a hypothesis for your experiment or your investigation will be. Okay, next we have either writing a procedure for your experiment or following a procedure. So if you are making your own experiment, you're going to state the exact amount of each material they use so others can repeat the experiment. Keep all variables the same except the one you change, which remember is called the independent variable. List the steps taken to complete the experiment. And remember, you need to do that so that they can follow those exactly. And then repeat the experiment more than once to see if the results are similar. You should at least repeat the experiment twice. Usually 3 times is best. If you are doing your own experiment or an experiment that somebody else has designed, then you are going to make sure that you have the exact amount of each material that you need. Make sure that you're only changing one variable, which is your independent variable. You need to make sure you follow the steps exactly in an experiment, and that's for your safety as well. And then repeat the experiment as many times as the lab says you should. The next part is actually doing the experiment. You do the experiment as many times as you are supposed to get the valid results that you need. You record your data on a data collection chart. So if it's numerical data, you write that down. If it's observations, which could be words, it could be drawings, you write that down on your chart. If it is numerical data, for instance, you may be asked to make a bar graph or a line graph. If you're making a bar graphs are used to show data that reflects amounts from separate groups. Bars should be the same width and have spaces between them. Line graph is used to show relationships or trends in data, measures time or distance or temperature. Your graph that you're going to do with your first lab, for me, will be a line graph. And then finally, your final step in your scientific method is drawing a conclusion. So you've done your experiment, you have your data, you've made your chart with your data and your graph. So you're going to draw a conclusion based on what you have found. So you're going to state whether your hypothesis was supported or not. That does not mean you were right or wrong. That means whether your data supported what you thought was going to happen or it did not. You're going to answer your original question that you started off your investigation or experiment with. Then number 3 and 4 on this screen right here are optional. You could state any inference you can make, like maybe you found some additional information as you were doing your experiment. Or number 4, you can mention any additional questions you might have that might have come up during your experiment. After you have finished this, you have completed the scientific method with your lab.